Now coming to the repeated measure ANOVA. So this repeated measure ANOVA, like which have you read any test which you think that it is very similar to this repeated measure ANOVA? Please type in the chat box. Yes, Prashant is right. Paired t-test. Sindhuri is also right. Kaushik is right. So it is the paired, it is like a paired t-test, where paired t-test you have seen that it is difference between the two paired values. So remember all those paired examples which we discussed. So yes, can you tell me one example of a paired value? Please type in the chat box. One example of a paired value. Pre-post, good. So if you have to do a repeated measure ANOVA, yes, RCT with drugs, but on this that can be there. Again, yes, pre-immediate post and 1 month post. Good. That can be one example of repeated measure. Where your left and right hand. Very good. So 2 paths program 3 times in a year. True. That can also be done. Any outcome which you measure. Maybe in educational setup, you have got a lot of example of this repeated measure ANOVA. So like all other, we will discuss first the 2 machines. Yes, 2 machines. So maybe this time 3 machines, Anuja. Maybe 3 different brands, or maybe one ambulatory machine, one the intermittent one. So 3 machines. You are true, right? So it either could be 3 different machines, 3 different season. If I take blood pressure in summer, winter, and autumn, yes, Priya is writing the same. So it will be the same set of people measured across 2 or 3 or more time points or interventions. So research questions, you all have answered about the research questions, assumptions and hypothesis, commands and interpretation, and then summary. So this one-way repeated measure ANOVA, which is also known as the within subject ANOVA, ANOVA with repeated measure, and it compares, because if you remember ANOVA, that was the between subject. This is within subject, and it compares the mean of the same study subjects at more than 2 time point. And here also you do the post hoc analysis. So what are the study design where it can be applied? So it can be like difference between 3 or more time point, like we have discussed. Priya have just said that change in BP during an exercise training program. Yes, one person also said regarding this workshop, maybe beginning, midway, and post intervention. The other could be like measurement of cholesterol level after 3 interventions on the same group, such as the 6 weeks exercise training and dietary control. So remember, the key point here is the same group measured. And obviously in this case, you will have a washout period in between if you are trying 3 different interventions on the same individual, or you can have a difference between the 3 or more change score. Like same studies have undergone 3 interventions, tested pre-post for all, and the change score you can measure. So what are the research questions? So if because this data is of COVID time, so maybe the all admitted patients. So what was the difference in CRP levels measured at 1st, 7th, and 14th day of hospital stay? What is the difference in post-operative pain score after 6 hours, 12 hours, and 24 hours of cholecystectomy? Does cigarette consumption varies amongst heavy smokers after the hypnotherapy program? That means immediately. There are 3 time points defined are the immediately before, 1 month after, and 6 months after the hypnotherapy program. So in all these cases, what have you observed? That there's a scale variable in each research question, and we want to compare average of it across 3 or more time points. Yes, glucose tolerance over a period of time. That is also true. So appropriate statistical test for such type of research question is the one-way repeated measure ANOVA. Now, what are the underlying assumptions? So the first assumption is that dependent variable should be continuous. The second assumption is that one within subject factor. In this case, one within subjective factor is mostly like 3 or more categorical variable. It can be 3 different time points. It can be 3 different machines. It can be 3 different interventions. So whatever within subject factor that you take, that should have 3 or more categorical levels. There should be no significant outlier in the dependent variable. Again, dependent variable should be approximately normally distributed in each level of within subject factor. And there should not be any significant outlier in the dependent variable. So the variances of difference. In this case, there we used to have something known as the Levine's test of equality of variance. Here, because it is the same group of person, so the variance will be different at each time point. And the variance of the difference between the all combinations of level of within subject factor should be equal. And this concept is known as the sphericity. And this is tested by a test known as the Mauchly's test of sphericity. Again, the same concept, if its p-value is more than 0.05, then this assumptions is met. But again, this is not always true, that many times you will see that this assumption is not met. In that case, we'll see what to do. So hypothesis, null hypothesis is there is no difference in population means of the repeated measure. And the null hypothesis and alternate hypothesis says that there is a difference in population means of repeated measure. So how to do that? So I'll go to the question. So a researcher, so this is like, I'll change it to Jamovie. So a researcher wants to study a new drug X, which is effective in reduction of systolic blood pressure in emergency hypertension cases. Further, it is planned to estimate the exact time point from where there is a clinical significant reduction in blood pressure starts after initiation of treatment. So the systolic blood pressure was measured every 15 minutes interval. So now I have to compare the systolic blood pressure measured over 1 hour period, that is at each 4 interval, at 0.0, 15 minutes, 30 minutes, 0, 15, 30, 45, and then probably 60. So there are 5 measurements. So how will I do that? So I'll go to this one-way ANOVA, and you can see there is an option of repeated measure ANOVA. So if you click this, now you will see there are 2 boxes here. This is a little bit different from the other options. Here you have to enter the name of the repeated measure factor. So this box is for the repeated measure factor. You have to enter name how many levels. So how many levels do we have in this case? We have got 5 levels. So I'll enter. Here I will write SBP. So I'll write SBP at 0. Then I will write SBP at 15 minutes. Then 30. So you have to define. You have to keep on adding. So since I have got this, I will write SBP 45 and then I will write SBP 60. So these 5 values I have entered. So similar, the moment you will enter these variables here, you will see repeated measured cells are now here, all these 5. Now I have to drag variable here. So I will have to look up for the, so maybe this SBP1.
मैम वो डेटा शीट एक्चुअली अनोवा का है मैम शायद।
वो मैंने इसका खोला नहीं है ना?
हाँ वो खोला नहीं है मैम।
Let me see. Okay.
अलग है।
हाँ उसका it's different. Okay, never mind.
Different.
Okay. You are right. Probably that's why I'm not able to see. So I will open this demo of repeated measure ANOVA. Let me see the variables first. That's the first thing which we should do. So yes, you can see here SVP 0, 15, 30 and 45. It is already there. In that case, I will go to the analysis and then go to ANOVA, repeated measure, the same, the way we have done, because you cannot, if you directly enter this now, here, although it will take, but you will see that it will not come in the result. It will, the result will be like, see, if I don't define, so now since only 2 levels are there, it is taking only 2 values. And again, result will be in the form of like level 1 and level 2. Okay, that's why you need to define these levels here. Maybe you can write SBP1, SBP2, because that variable it has been 2, SBP3, 4, 5. Now I've entered, now I can enter this one, I'll move back, 15, 2, then 3, 4, and 5. Now it's complete. So you see the value of repeated measure and you can see that this is significant. But in which group it is significant, that is not clear. So here you can see those things which we studied, the sum of square and degree of freedom. That is there. So you divide this, if you divide this by this, you will get this mean square. And then this is your, you can see before that, we will go with this assumption check. So assumption check, you can see sphericity test. So I will click this. It is the Mockley's test of sphericity. And the value you can see here, sphericity is the p-value is less than 0.001. So if p-value is, this, if it is less than 1, that means the assumption of this thing is not met. In that case, you have to take the value of greenhouse gazer if the Mockley's test of sphericity is not met. In that, you can do the correction. So I'll do probably the greenhouse gazer correction. And that you can see here. Then coming to the values, post hoc test. You want descriptives also. Model, I'm not doing anything. It is not assumption check I have done. QQ plot, you can check. So it will give you the QQ plot. You can see it is approximately normally distributed. And then post hoc test. You will move these variable here. And then it will give you the post hoc test. So you can see it will give you the value of post hoc, like difference of 1, 2, 1, 3, 1, 4, and 1, 5. This is the mean difference. This is the standard error, degree of freedom, t value, and this is the p value of two keys. So you can see that it is significant. So all pairwise comparison is significant. There are other options also like Sheaf, Bonferroni. It is up to you, but generally 2Ks we apply. So this you can do. So and how will I write? So you have to paste this table and then you can report this eta square also. In case of this, we report partial eta square. So you can see here that F value, P value, and eta square. So eta square, it is 0.8. That means the effect size is very good. So this is regarding the repeated measure ANOVA. And so how will you enter the result? So if you see the result, this mean and standard error. So let me see from where this descriptive has come. This option is, if I click, there is a group summary. And I cannot see descriptive here in this option. So maybe descriptive will have to go from the descriptive option. Mean difference it is showing, but the descriptive table. And in this case, you will have to report this greenhouse gazer because I have applied this greenhouse gazer correction. I'm just looking whether in this option we don't have. So for descriptive, you will have to go to just a sec. Let me see. So if you want estimated marginal, I'm not giving them the concept of estimated marginal mean. Okay, then I have not told them actually. So let's not tell them right now. So leave it for now. You only estimated marginal mean because that we'll learn in the higher concept. Till now only go for this. So this is the greenhouse gazer correction I have applied because the sphericity was not assumed. And this descriptive, yes, I'm repeating everything I'm repeating. Descriptive, you have to go through this exploration. I'll tell you once again. So what I do, I'll again, should I tell from the beginning, Dr. Chintamala?
Yes, madam. Yes, yes.
So I'll move everything. I'll cut this, even delete this. So initially it is like this whenever you open. Okay. Now, if you open this, you have to enter the repeated measure factors, which is this RM factor. Can you see this RM factor? This is the repeated measure factor. So Dr. Chintamala, what we are doing, we have to enter the variables. Now you can see there are only 2 levels here. So if you don't create factors here, it will not take. So you should have 5 factors. So keep on pressing enter button, then you will have these 5 factors. So this is level 1, 2, 3, and 4. Now whatever is written here, if I show you, whatever is written here, that will be shown here. Cells. So I need to define this, otherwise result which will come, this will come under the heading of this level. I don't want my output to be under the name of level. That's why I need to rename this. That's why maybe I will write here that SBP1, or you can write at SBP at 0 minutes. You can copy the same, you can write it here, paste, and then change it to 15 minutes. Again, you can do the copy pasting also because it's the same variable. So 30 minutes, again paste it, 45 minutes, then again paste it. And this is your 60 minutes. So I have now defined these levels. And once you have defined this, can you see that these levels, and this is with the same name. Okay?
Yes,
Are you getting, Dr. Chintamala?
yes ma'am. Yes.
Okay, so if you have understood up till this level, so now we need to enter our variable here. Can you see a very faint line is written here, drag your
Drag
variable.
variable. Okay.
Drag variable every time. Can you see?
Yes ma'am. Yes ma'am.
Okay, so if you can see this, now I will enter this 0 under this 0, the first one.
Okay.
Then 15 in the second one. This blue line, can you see this? There is a blue line
Yes ma'am. Yes ma'am.
which appears, this blue line. This blue line, appearance of this blue line means that this cell is active now.
Okay.
And then you can enter. If you have entered, I will again shift here. I will enter 30, then this 45, and then this 60. So if I have done that, you will see that there is a, so right now, before all these, I have unchecked that. So initially it will be like no correction. So in assumption check, what assumptions did we have? That it should be approximately normally distributed, there should not be many outliers, and that you have checked in the descriptives in the beginning, I'm assuming. Now there is another assumption here in repeated measure ANOVA, which is the assumption of sphericity. Sphericity means difference, like if there are 5 different measurements you have taken, so difference between the 2 variances should be equal to 0. That is the assumption. If that is met, you will take this, you will not do any correction. If that is not met, you will do correction. And that correction can be form of the greenhouse gaser or Hunfield. You can opt for either. Let's say I go for greenhouse gaser. So how to decide whether you have to do any correction or no correction? Like remember in independent sample t-test and in one-way ANOVA, if that assumption of sphericity was not met, what we used to do? Can you please tell Dr. Chintamala?
Not getting madam here.
Like, can you recall your one-way ANOVA?
Okay.
Were you there in the breakout room, Abhi activity?
Yes ma'am. Yes ma'am.
Okay, so if that assumption is not met, what we used to do?
Other test called the
Other test, where it was written that equal variances not assumed, Fishers. Okay, so similar concept is almost similar, that if sphericity assumption is not met, instead of no correction, you use this greenhouse gaser. So you can have an analogy from a Levine's test to this Mauchly's test of sphericity. Okay. Its name is Mauchly's test. If I click on sphericity, you will see here test of sphericity. And what is the name?
Clays test.
Yeah, this one. And we see this value. So maximum time, all standard textbook, they says that usually this assumption is very difficult to meet. So most of the time you will be reporting it with the greenhouse house gazer correction. So what you do, because it is not met, remember all named test p-value should be, if it is more than 0.05, then only we say that the assumption is met. In this case, the p-value is
Less than 0.001.
yes. So it is less than 0.05.
Yes, ma'am.
Do you agree?
Yes, ma'am. Yes, ma'am.
Then this assumption is not met.
Not met. Okay.
If it is not met, then you will do what you will do. You will do a correction.
Correction. Okay.
And instead of none, you will click this.
Greenhouse
So the same here, you have to report this value.
Okay, ma'am.
Okay.
Okay.
It gives you some correction where this degree of freedom that comes in fraction. What Vikram was talking. Remember, by mistake, Vikram thought in one way ANOVA that 2 and 177 as a fraction point. That time he was wrong, but this time he is right. Because in repeated measure ANOVA, you get degree of freedom in points because of some correction factor. Okay. So this you have to report. Degree of freedom in fraction, the value of ANOVA F, and then p-value.
0.00.
Yeah. So it is significant. Now you can say that the 5 systolic blood pressure measurement after giving the drug, because remember what was the question? The person gave some drug and he wants to see after which time there is a decrease in the blood pressure, maybe for hypertensive emergencies. If you want to treat hypertensive emergency and you have developed a new drug and you want to see that if it decreases blood pressure after 15 minutes or 30 minutes or 45 minutes or so on. So now what you will do? You want a pairwise comparison now. And in this case, again, these QQ plot homogeneity we don't test here. So if you have to do this post hoc, now you can see here it is written RM factor because I have not changed the name here. Must be RM factor. See?
Yes, sir.
So you write SBP here. If you have written that, you will see that here SBP will appear. Now you have to move this to this post hoc test. And in this post hoc, you will see that it will tell you the difference. So now, again, the same which we used to do the post hoc of ANOVA. How to read it? So the first row, it tells you the mean difference between SPP 0 and 15 minutes. As the second row, SBP 0 and 30 minutes, SBP 0 and 45 minutes, and then SBP 0 and 60 minutes. The 15, 30, 15, 45, 15, 60, and likewise. So it gives you the mean difference, standard error, and the degree of freedom, T value, and the P value of 2 keys correction. But that's descriptive. For the descriptive, you'll have to go to exploration. Descriptive, you want mean and standard deviation. So you will shift these variables here. That descriptive in ANOVA, you get the descriptive there. Here you have to go to the statistics. This mean and standard deviation. You don't want minimum, maximum. That if you want, so this is the way, SBP 0, 15, 184, 14.6. This is the mean and standard deviation. This one, which you have to report. So you can see that the blood pressure decreased from 184 to 133 at the end of 1 hour. Okay, did you get it? Anjana is asking, elaborate on sphericity. Okay. And there's one more person who's asking me to repeat. Let me see. Lag in voice. Okay, is it my voice? Is it lagging? Okay. So Haripriya is writing me eta square and it's cut off. Okay. Okay, so I'll repeat once again. Voice okay, Vikram and Snake are saying. Okay. Anyways, So did you see we have to go with this descriptive? Again, I'll go here. This sphericity. So now, why it is known as sphericity? Why not as a variance? Why? Because it is the same group, which is the tested at different point of time. Same sphere, yes, true. So if you can imagine in a circular this thing, so it is going like a round movement. Like if you take this 15 minutes, 0 minutes, 45 minutes, and 60 minutes, just imagine it in a circle, or maybe then you will see the difference of variance between 0 and 15 minutes. There will be some difference because now again recall that variance. How do we calculate variance? Mean and then at that point of time. And then individual variation from the mean, square it, divide it. It will have some value. Then again 15 minutes will have some value. Then again 30 minutes will have some value. So it says that difference between the two time point means 15 and 30. It should be equal to the 15 and 0. And it should be equal to maybe with all pairs. All possible pairs if you can think of. So difference between the two variance, it should be equal for all pairs. Okay. That is known by sphericity. So can you get it? Let me see the names who asked this, then maybe Anjana. So Anjana, did you get it? Like there will be many pairs of these variables, 15 minutes, 30 minutes, 60 minutes, 45 minutes. So you imagine two pair and just see the difference of variance. Okay. And it says the difference of variance between two pair, it should be same between all combinations. That's why we always say that it is difficult to met. And you will read in most of the textbook that it is very hardly met. So normally it is violated. That's why it is always reported as a greenhouse gazer correction. Okay. This is the Mocklay's test of sphericity. So just recall your concept of variance. Apply that variance between the two different group. It is the same group actually, but at two different time points or at two different intervention, whatever repeated measurement you are taking. And then these difference of variance across any two combinations should be equal or nearly equal. That is the assumption of Mocklay's test of sphericity, which is difficult to meet. That's why it is always reported with the greenhouse gazer correction. And one more thing, initially I told, okay, thank you, Anjana. Any other point before I go to this eta square or partial eta square? Yes, same. Either you can go with the greenhouse gazer or Hundfeld. Both are the option. There are two people who have suggested these corrections. So both can be accepted and there's no criteria what to take. So in literature, you will find both. And there's not much difference also. Like if you click both, then see what happens. Like even if you click this, see its value. It is very less, only in form of some, see? What is residual in this table? So residual is basically the difference. What is residual actually? So residual is in this case, basically it is the like there is a within group and there is a between. So this between, if you see this mean square and degree of freedom. So what is the degree of freedom? What is the total sample here? 586. Can you see? If I click none here, let me click none first. So in case of none, what is the value here? 768. So how come this 768 has come? So this 768 is the total number of repetitions. Okay. Like if I take total sample size here, what is the total sample size? Maybe the 193. If you multiply 193 by 5, because there are 5 measurement here. So 193, where is my calculator? I can do here also.
960.
193
960.
multiplied by 4. Let me see. 772. And then we will remove this minus 4 because this measurement is that's the way we calculate the degree of freedom. Means 4 different time points. So this residual is basically all those measurement it takes in total. And then it calculates its sum of square. That means overall. This is again this 80,662. That is the again sum of square of those individual type of repetitions which was done. Okay. Prashant is writing n minus k. Yes. So this is how we do it basically. So if you have understood this, it's the repetition only, the repeated measure. So those many residuals is overall mixture. Yes. So now if you have done this, it comes with this interpretation. So this is the mean and the standard error which we have calculated from the descriptive. This is a statistical test. That means the Mocklay's test of sphericity and greenhouse gazer correction values. And this is the same table which you have seen. This we have pasted here. And this is the write-up. So one of you can read the write-up for me. I can see Vikram's name at the last before Ria.
Sure, ma'am. Hope I'm audible.
Yeah, you are audible.
Okay, ma'am. So, interpretation: a one-way repeated measure ANOVA was conducted to determine whether there were statistically significant differences in SBP over the course of 60 minutes after the initiation of treatment. There were few outliers each in SBP at 45 minutes and 60 minutes, as seen by the visual inspection of the box plot. The outliers were kept in the analysis. The data was normally distributed as assessed on visual inspection of QQ plot. The assumption of sphericity was violated as assessed by Mockley test of sphericity with, I should written chi-square and x-square of point.
It's degree of freedom. It's a chi-square statistics. So
Okay, ma'am. So chi-square of 0.55, p less than 0.001. So therefore, a greenhouse gaseous correction was applied.
This is a part eta square. I forgot to tell that. Once you read this, I'll again tell that.
Okay, ma'am. The treatment elicited statistically significant changes in SBP over time with F 3.06 to 586.77 is equal to F value of 1001.6 and P being very highly significant. SBP level showed a decreasing trend from 30 minutes time point. Post hoc analysis with the Bonferroni adjustment revealed that SBP level was statistically significant decrease between all pair of SBP value except for baseline versus 15 minutes time point.
Okay, thank you. So this is one way of writing interpretation. There are other ways, like you can have your own write-up also, but this is just one way. And Prashant is also writing that the variance that is not explained is the residual. That is also correct. And in that repeated measure ANOVA, if I see this, there is something known as the eta square. So generally we click this partial eta square, that is the effect size, and this eta square tells you the value of that effect size. So the value is 0.8. So we have again done that if the effect size If it is up till, there are three levels, 0.2, 0.5 and 0.8. So up till 0.2, we call it no effect. Up till 0.5, we call it as a moderate. And if it is 0.8 or like 0.5 to 0.8 and more than that, then we call it as a very good effect size. So this is the interpretation of effect size. So that's it with the repeated measure ANOVA.